name is Michael Feathers. I'm your keynote for this evening. And I just wanted to put this word up here to scare you guys to pieces. So how many people are sitting there thinking, oh my God, he's going to talk about standards and stuff like that. And I'm looking out there, I'm looking and I'm seeing you guys like this. What the hell? You invite this guy who's going to talk about standards. Now, I'm not really going to talk about standards all that much, but I'm going to use this as a way of segueing into what I really do want to talk about over the second part of this talk. Anybody ever come from a place that has a coding standard at all? Yeah, I know it's not, well, many people still have a coding standard. Yeah, I know. With the Ruby community, quite often things are a lot looser and stuff like that. But many of us in the Ruby community have really been, in a way, refugees from other organizations, other cultures. So you have, big IT departments and big standards and all this other crazy stuff. And it's really interesting to me because we tend to hate this sort of thing, right? At least I know I do. It's a strange thing that you have like this set of guidelines that you really should apply to your code, not only your code, but also the way you're interacting with your tools and various things, the way you interact with the rest of the organization. Standards are ubiquitous, but they're also a bit painful for us. And this really kind of struck me a while back when I was reading this blog, a couple of days ago, actually. This guy, it's a very nice rant by Eric Dietrich, talking about how we get coding standards wrong and what they're meant to be, and all the crazy things that happen. And he goes into this big, long story about sitting in the conference room with all these people kind of arguing and ending up with like a group think about what they thought would be the appropriate standards for their team. And of course, you want to make everybody happy, so everybody kind of says, well, yeah, it's like, yeah, a little bit of cherry picking. It's kind of like, yeah, you want to do this thing, I want to do this thing. That's a good idea too, and that's a good idea. So let's put all this in our standards document. Let's do this in order to go and establish the way that we want to work together and establish the way we want to go and approach our code. And like I said, he rants and he rants and he rants. And one of the things that he kind of points out is that when you have coding standards in an organization, quite often what you end up with is this, pointless homogeneity. You have this sense that basically things have to be uniform all the way across in the code base, and that there are certain things that are just purely good ideas. And because they are great ideas, that's what we just want to do, right? And so, of course, it's like, it's like having, let's say, things like the way that we use modules in our Ruby projects and stuff like that. This is considered best practice. Let's just go ahead and do this, uniformly throughout our system. And that really grates me. It really grates me in a very deep level. And I try to think a bit about why that happens and what it means for some of the other things that we try to do as we're programming. One of the things that we really want to do as we're programming is just really arrive at better designs, right? And it seems that coding standards are really kind of about that sort of thing in a way. What we really want to do is basically sort of like, and when you think about what a standard is, think about standard tooling, like in mechanical things and stuff like that. What we're really doing is we're basically trying to go and sort of like minimize variation against some standard, right? And in essence, that's what standard really is. It's a way of targeting a goal by comparison against a fixed point. Yeah, kind of abstract, but it's, that's just kind of what standards are all about. So let me hop over to something different. Anybody saw this the other day? I was reading this on Hacker News that apparently YAML is moving from Scala to Java. Anybody hear about this news at all? And how much of you are in touch with some of these other things happening in different language communities? So Scala is a nice language. It's been around for a while. It kind of takes a base of Java and goes and enhances it in a very nice way. It allows you lots of functional programming constructs and all these things. And many organizations are adopting it, but this one organization said, hey, we're having trouble with this. We're going to move back to Java. And so one guy wrote another guy an email, and then it was leaked. It went up onto GitHub, and there was a big discussion about the entire thing. And this started to really grate me. And the reason this really started to grate me is that as this guy started going and describing the reasons why they were moving away from Scala to Java, they started talking about performance, right? And they said, we have problems with performance in Scala, and we got 100% improvement, or 100 times improvement in a lot of our areas of code just by going and doing these things. Don't ever use a for loop. Don't ever use Scala, clutch immutable, and just a whole list of other things like this. And I kept looking at this and like, oh my God, that's just, there's something really wrong with this. I don't know, how many people have done performance tuning work before? Right? Yeah, everybody does. So are all areas of your code equal when it comes to importance and performance? No, not at all. So doesn't it seem kind of weird to go and have particular guidelines you're going to go and use uniformly all the way across the code base, right? So whether you use a for loop or not within Scala, or whether you use immutable and stuff like that, really should depend upon the area of code you're working in and what its performance characteristics happen to be. And if you start to go and sort of like apply this one standard uniformly across the entire system, you can be in a bit of trouble. So of course I'm reading this and I'm going like this. It's kind of like, no, don't you get it, don't you get it? These things are things that really matter. Basically, context matters so much when you're having these kinds of discussions. And the same thing is true with things like coding standards, right? I think there's something really common between these two things. And it's kind of like this. When I look at it metaphorically in my mind, it's kind of like this. Anybody know what distortion is in audio? You know, it's kind of like when you look at an audio signal and it has distortion, and usually, you know, in music you hear that nice little hum that you get with like a, you know, an overdriven guitar or something along those lines. What's really going on is the signal is clipped at the very top and at the very bottom, right? Instead of having that full, nice flow across the signal, the top is just clipped off and the bottom is clipped off, right? And in roughly the same way, it seems like there are many things that we have an urge to do when we're programming. They're kind of like this. Take this particular thing in it and basically apply it uniformly across the system. When I look at this, it's almost like somebody took a plank of wood, just like sliced off the top of, you know, the signal, or just clamped it down. And so you end up with having this, like this plank of wood used as a golden hammer, in essence, you know, sort of like solve your problem. But this strategy of going and saying we're going to take some guidelines and apply them uniformly across all the things we do is not very empowering. And it's kind of sad in a way. So see if you guys are with me. So standards, uniform corrective action, talked about a couple of different things here so far. Let's kind of go and transition this over to a discussion of something closer to design. Design principles. I guess you guys are aware of some of them, like, I mean, what the single responsibility principle is. You hear about these things, an open close principle. The solid design principles are like a nice basis for going and orienting yourself as you're going and doing object-oriented design. And you know, they're written up in many various different places. And the thing that kind of gets me about design principles is they're kind of abstract. It's kind of like you have this notion that, well, you know, particular classes should look in particular ways, and if they do, it's good. If they don't, it's kind of bad. And again, you're not really looking at context when you do this sort of thing. But it's very easy for us to go and have these kinds of criteria in a team or in our minds about these things. You could say your code should conform to the solid principles, right? It's a very abstract thing to say, and the people who are aware of these things, you know, kind of, you know, they know that they can do this sort of thing, and they basically just try to occasionally. Your code should be restful. Your code should be dry. We know all these things, right? Now let's go and turn this around a bit. Principles are kind of like sets of ideals. It's kind of like standard in essence. We're trying to go and basically measure our stuff against a particular ideal. Hard gauge, a plank, like I was talking a little bit earlier. But what are we really trying to solve when we do this? That's the thing which I think is important for us to consider. What I want to do when I'm working with teams and working myself, you know, on projects, is I want to encourage deliberate design thinking. I want to not have some abstract standard that you apply uniformly across everything. I want instead to think about what really matters in this context. And so the thing I've been kind of like coming back to with this a bit is that maybe we can do something a bit different when we're having discussions on the team about what good design happens to be in our code bases. And so what I think is an interesting idea is that if you're working with somebody, if you're working with yourselves, to go and have this thing where you basically sort of like try to run the gauntlet in the code that you write and try to go and basically challenge the things that you've done and ask questions as you're doing these things. And as you ask these questions, they should lead to further thoughts, and you might choose to go and basically alter your design a bit, make things, you know, a little bit better in some dimension. But we all do this to some degree. I think we can be a little bit more proactive about it. So what I'm thinking about is this. Basically going ahead and practicing guidance within teams as design challenges. Ways that you can challenge the designs that you happen to be working on. And you know, here's an example of that sort of thing. Okay? Suppose you're looking at some class in some system, and you're working with somebody else, and you just bring up the question, can we split this class into 2 pieces, or 3 pieces, or something like that? All right? Let me get the irony here. I'm showing you a .NET class. So maybe we'll catch that, right? But that's an interesting question to ask, right? Now, the thing is, if you can answer that, you can look and say, oh my God, you know, it's a big class, we can break it down into smaller pieces. Then you can have a discussion about whether it's really worthwhile to do that. Is there a design principle associated with this? Single responsibility, right? It's kind of like the notion that Every class should have some single core, some single responsibility. And when you ask this question, when you look at a big class and you say, wow, could I split this into 2 pieces or 3 pieces or something along those lines? It may lead you to think, oh, wow, that's the right solution in this context. Or you might go and say, well, I can kind of see that I could split it, and I would name the class this way, and I would extract this other class and give it this name. But I don't see too much benefit to that now, so I'm not really going to do that sort of thing. But at least you can have a conversation. You can think about that sort of thing. And this is like a challenge you can have against your design that you're working with. Another challenge, I'm working on a particular class right now. What's going to cause this class to change? Think about different requirements that could come up in your application, different features that people might want. Would this particular class be a place where you would actually go ahead and make those changes? If you did make those changes, would it become a bigger class? Would it be less focused? Would it be more confusing? Why would you be tempted to change this class as opposed to some other class? These are all questions you can ask yourself as you're writing code. And the thing is, rather than just talking about abstract things about good design, that this should be a class with a single responsibility and all these other things, we can ground this entire thing by going and talking about the potential, the things that can happen in our code base. And this can be a rather valuable approach. Other things. Will all of it change? Okay, this kind of focuses back in on that single responsibility thing I was talking about a while back, that if you have a class with a single focus, a single responsibility, if you make changes to it, it shouldn't be the case that you're changing maybe 3 methods out of 10 or something along those lines. If that's the case, then maybe you have more than one responsibility hanging around in the class, but you can go ahead and ask this question periodically as you're doing your work. What's going to cause this particular thing to change? What about this one right here? How hard will it be to change this class if the number of clients grows? Okay. Is there a design principle associated with this one at all? There's one called dependency inversion, which is kind of abstract, but this brings it home. Okay, if you have some class and it looks like as it's being used more and more and more and more throughout the code base, it's going to be harder and harder to go and change this class because of all the ways that other things go ahead and interact with it. Bad deal in design, just not really a good thing to go and deal with. Will anybody surprise the user of this object that you're working on? Okay? Will anything surprise the user of this object? And yeah, this is a nice thing to be aware of, right? I mean, you don't want to surprise yourself or other people in bad ways, right? So this comes down to proper naming. It comes down to, if you're using inheritance, having this being properly substitutable across the different areas in the code base where it might be used. Just a nice thing to ask yourself about how you do things. Here's a great one. What happens when this fails, right? This is almost like a basic engineering mindset. I think anybody who's been involved in programming, regardless of when you started with it, you basically discover that the computer doesn't always do what you want to do, and you have to kind of think proactively to go and discover what kind of things might happen when things go wrong, right? But we can be very explicit about it, okay? Ask yourself periodically, as we're writing code, what do we do when these particular things happen to fail? What do we do when something happens that we don't expect? All these things. Here's another one. How many things do you have to understand this particular piece of code that I'm working on right now? This one takes a bit of work because by the time we're starting to ask a question like this in the code base, we're already soaked into it, right? We already know all the stuff, but trying to look at it from with fresh eyes, and say, hey, here's an area of code that somebody's going to look at some point in time in the future, and it won't be me. How much else do they need to know and understand about the system to be able to go and change this code effectively? And that's really the core of just trying to do good, clean design. Trying to go and get things into a state where it's easy to modify, easy to understand. And we can be very, very reflective about that. What happens if somebody outside the team wants to change this? Okay. Is there some aspect of your code which somebody else is going to go ahead and modify, and they're not going to have as much context as you? It's kind of related to the previous one. And in open source, this happens all the time, but it's nice to go and ask, gee, what kind of changes do you expect people to go and add in? What's going to happen when they add those things in? Do you need to have an extension point here, that you might be useful for them? A little bit of forethought kind of helps with these things. There's other things we can look at too. Okay? Applying this to the longitudinal view. And this is a real whopper. Nobody really does this. Okay? Quite often, when you can look at it from the point of view that when we're designing, we make lots of design decisions, and once they're done, we don't think about them all that much. And I can't tell you the number of teams over the years that I've been involved with where they kind of paint themselves into a corner. They kind of, they make an early decision about the use of a particular platform or a technology or a particular style of coding or a particular style of design. And then they find maybe 6 months, a year and a half later, that they want to go and change their code base in an unanticipated way. And they discover that all the forces are aligned against them because they made a very early design decision. And they didn't realize what the ramifications of that would be. The thing is, you can do something about this also. You can ask yourself periodically, when you make a big design decision, you can write it down and keep track of it and go ahead and ask yourself, gee, if I had to change this now, how much would it cost? And then ask in another month, if I had to change this now, how much would it cost? Imagine you're using some kind of like an ORM, like persistence framework that goes and handles all the database interactions for you. And you discover that over time, it's really hard to go and move away from it. Have you ever see that happen at all? Yeah. So, no, and you can ask yourself about these things. What's funny about this is that if you do this in projects, you start to go notice that there are certain things that kind of grow linearly, right? It's kind of like, particularly like the persistence framework thing. As you add more classes using this, you've got more you need to undo if you're going to go and change things out that way. And yeah, those things are the ones you have to kind of watch out for. And again, that doesn't mean don't use something like that. It just basically means be aware that for particular things, you're going to, over time, go ahead and have increasing cost, increasing cost, increasing cost. You may never have to go and actually pay that cost. The day that you actually make a different decision, you will. And that may be a very fair thing if you don't think that's ever going to happen. You just go and say, okay, yeah, sure, I do this, I do this, I do this, I do this. And if we never have to go and change out this framework or something like that, then it doesn't hurt at all. Okay? On the day that you do, you might. But we can be very conscious of this sort of thing when we're doing our design work. So next week, next year, so and so. Another cool thing about this, too, is that we don't have to do this sort of thing incrementally over time. In a team, one thing you can do is you can go ahead and sort of mine your source code repositories a bit and look back at code as it looked a year ago and ask yourself, at that point in time, how much would it have cost at that point in time to undo this design decision? And you can do a little bit of a ballpark estimate for that sort of thing. Fast forward 6 months. Ask yourself the same question. Oh, wow, now it's really painful. It was painful before, now it's way more painful, such and such. I think we forget quite often that in our projects, because of our massive source code history, we can do an awful lot of looking back and playing through scenarios to kind of figure out what would have been the better decision to make early on. And to the degree that we do this, we can be very conscious of things. And if we're very conscious of things, we can make better decisions and avoid some trouble. So these aren't new ideas. It's kind of close to something. There's a woman in the industry, Mary Poppendick, who has been involved in lean software development. And she introduced me a couple of years ago to this book called The Checklist Manifesto. And it's really interesting because it talks about ways people have kind of improved process in other fields, like medicine, for instance. It's like apparently surgeons have certain checklists they go through before doing such and such. Pilots have the same thing, and it's, it looks boring, right? You basically go and say, look, in order to go and do this, to guarantee that I'm ready to take off, I do this and this and this and this and this and this and this. But it does give you a level of rigor and safety that you wouldn't have otherwise. And I'm not saying that we need to have that sort of thing all the time when we're coding, but I think that what we can do is we can start to go and have conversations among ourselves about the kinds of things that can happen in the code base and use that as criteria for whether we're working on something which is good or not, whether we're actually making something which is good or not. And yes, design principles, I think it's a great thing, but I feel right now they're a little bit abstract for the kinds of things that we would like to do. Having a conversation about, hey, what could happen in the future here? What if this gets undone? I mean, those are very easy conversations to have. You learn an awful lot about how to go forward in the code base. I tried this years ago in a strange way. Years ago, I was finding, prior to my work in Rails and Ruby and stuff like that, in working in other languages like C++, Java and other languages, I found that people that were writing unit tests were getting into all sorts of trouble. So I just sort of made this little checklist of things that they simply shouldn't do in unit tests. And of course, I got a lot of grief for it because they're like, oh, who are you to tell me what I can't do in a unit test? And my unit test touches the database and it works fine for me. And I'm like, yes, 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 yes. So of course, I added that last little paragraph there saying, well, I'm not saying you don't ever want to do these things, but think about it if you are. Call them something different. It's nice to have these little things to kind of check for, to think about as you're doing your coding. And I really don't, every team's going to go and, any team that wants to go and practice this sort of thing is going to do it in a different way. Just be a matter of informal conversations. I think it's great in a team to go and just sort of talk about the things which cause trouble, and then go and ask yourself, gee, rather than having a hard standard where you say, we're not going to do such and such, which is kind of like what this is here. Instead, you want to go and ask these questions, which are really about, what happens if we do this? What is the result of doing design in this particular way? And that's a far more open conversation than just going and saying, don't do this, which gets us back to coding standards and that kind of like hard limit that I think is kind of painful for us. Am I alone in that? You like hard limits? Do I like hard limits here? No, okay. And going back, this kind of reminds me of something that was written up a long time ago, a totally different field. Music. Anybody heard of a guy named Brian Eno at all in music? Yeah, he's been involved in music for ages and really a pioneer in electronic music. But early on, he did this interesting little project. He made these cards called oblique strategies. And they were just little things that basically cause you to think of it. And I kind of see this sort of thing as being like that in a way. Not a hard thing that tells you what to do, but rather things that help you think about how you make your decisions when you're doing your work. And I don't know. So it's an idea. I kind of hope that you guys get a chance to try it out. I think the idea of moving from design principles to design challenges is kind of like what the industry's done a bit with TDD and BDD, right? Remember in the very beginning, all these things were called tests, and then a bunch of people kind of jumped up and said, hey, we're going to get some benefit out of calling these things specifications. We're going to get some benefit out of thinking about them in terms of behavior as opposed to testing, that kind of thing. And there was a lot of pushback against that because people were saying, oh, no, you're just changing the name. It doesn't really mean anything. But it's really a change in emphasis, and that's kind of powerful also. And so I think this idea of design challenges is something that we could possibly use in the industry to try to go ahead and sort of frame conversations a bit better about the stuff that we want our design to be. I mean, provided we're actually having those conversations at all. Some teams don't, and that's kind of sad. So really, the goal is to think, okay, to have deliberate, reflective design as we're going and making our changes and doing things in the code base. As the guy who wrote the legacy code book, I can tell you, I know what it's like when people don't think, okay? I see the results all the time. I'm sure if you've been in the industry for a while, you know what it's like also, right? And we want to avoid that, so I hope this is helpful. And I have to put this up also. Anybody know what this is? Well, I've heard a lot of talk about DCI, so some DCI. All right, thank you very much.